Hello, my name is Azri Samrudin Kimin. This is my final year project, the Smart Integrated Control System for the Pyrolysis Process, or known as SITCSP2. This project is done with collaboration with Associate Prof. Dr. Asrul Nizam Abdul Manaf and the team from the Collaborative Microelectronic Design Excellence, or known as SEDEC. They will be providing information about the software and hardware part of the system. And then there's Dr. Owenda from School of Chemistry USM. He will be helping for the technical part for the machine. For the background, we first need to know the definition of pyrolysis. Pyrolysis is a thermochemical treatment that can be applied to upcycle plastic waste. During pyrolysis, the plastic waste decomposes at high temperature in the absence of oxygen to produce various byproducts, which can be used for many applications. This machine, Carbolite 0TF1, will be used along in this project, and its main purpose is to convert plastic waste into byproduct through pyrolysis process. So the problems in this project is that the temperature inconsistencies due to variety of plastics. So during the pyrolysis process, the temperature will be inconsistent as there are many type of plastics that needs to be considered. And to solve this problem, we need to establish plastic temperature profiles, each of them, including single or mixed plastics, and we need to regulate the temperature using machine learning. The system objectives is to develop and obtain the temperature profile and heat distribution of selected single or mixed plastics during pyrolysis using the smart reactor system. And it is to develop an optimization module during pyrolysis using machine learning. And lastly, it is to integrate a smart control system incorporated with machine learning for temperature optimization during the pyrolysis process. So this is the overall module diagram. We have temperature control module, user interface module, cloud database service module, temperature profile module, and the machine learning module. This is the full system architecture diagram. So here we have our furnace machine and the controller. This piece of hardware is connected together, but and you can simply run the furnace machine through the controller. But to make the system work, you need another piece of software known as iTools. This iTools will be used along with the controller. The main purpose of the iTool is to extract the data from the furnace machine, which can't be done through the controller. And the controller is connected to the iTools using an Ethernet cable. So after obtaining the temperature profile, after doing some pyrolysis process here, and then we will be converting transferring those data into the cloud services and storage. And then the data will be extracted into the software application and will be processed for the machine learning part. And then after we obtain the optimal temperature, the data that we want, we will be we will be sending those information back into the furnace machine through the iTools and then into the furnace machine again. So for the implementation of AI, we will be using artificial neural network. It is so first we need to collect temperature data, and we will be doing some data cleaning to obtain uh, more quality data to be trained, and then we will divide the data set into training and testing, and we will be doing some hyperparameter tuning using manual grid search, and then we'll be selecting the optimal batch size and epoch for the best model with highest accuracy, and then we'll train the artificial neural network model. For the dataset, this is the dataset that I've acquired from open literature from the internet. And this provide the initial data training for the model to train early on, and then after I get to work with the machine. This is the data set I've acquired from actual experiment that I've done with the machine. So this is the example, and this is the information that are extracted from the iTool software. And this is the sample of byproduct. This is the PVC after the pyrolysis process, and this is the HDPE plastics done after the pyrolysis process. All of this experimental data are acquired from Lab Assistant. For the hardware and software specification, this project uses the furnace machine and my own laptop for the whole system. And then there is the iTool software applications, the newly developed SITCSP software application using Python programming language in the Jupyter environment. So now we will progress to the demo. So for the demonstration, here is my software, the SITCSP software. This will be used to insert the parameter, and we'll be predicting those parameters using machine learning for the optimal temperature and heating rate. And then we will also be storing those data into this database for future references. And here is the iTools program. This here we'll be inserting the parameter that we need to run the machine itself. So first, let's say for the we want to just use one plastic, which is PVC. So the weight percentage will be just 100, since we will be using a single plastic, just PVC, and then the others will be 0. The particle size, let's say, is 2.5 millimeter, and the feed size of the machine is 100 gram. For the catalyst, we just put no for now, and then we will be predicting the optimal temperature and heating rate. So the optimal temperature and heating rate here is 400, and with heating rate of 5, with predicted maximum oil yield of 70 grams. So after we acquire this information, we will go into the iTools. So we will target the set point to 400, 400 here. And then the burn rate, we will set it to 5. And for testing purposes, we just be setting this, the constant time for it to burn. We just set it to be 5 minutes. And then the cooling time, we just set it to 10 here. And then we'll run the machine here. We'll be running. And then all the information here is displayed. So the program time left, it still has 2 hours of running, and the target set point is 400. So right now, the pyrolysis process is actually running. So here is the controller, and here is the actual machine that are connected with my laptop using Ethernet cable. And here is actually the controller, and all that is displayed here are also displayed on the iTools software. So the number here is the temperature. We set it before to 400, and so it will be increasing at the rate of 5 degrees per minute until it reaches 400, and then it will stay there. It will stay there for a total of 5 minutes. So here is the increasing rate. It will be until 400, stay there for 5 minutes, and then it will go down. And then it will produce the byproduct from the plastics. So after we acquire those information, we will be inserting those into the database here. So after the program is done, we will say that the temperature we set is 400, the heating rate is 5, the value that we predicted here is 70 gram, and then the value that we acquired after the program is finished, we will be inserting those here. So for the demonstration, I actually don't have any plastics. We just run the machine. So let's just say just maybe 72, and we'll just enter into the database here. So that is all from me. Thank you for your time.